zero knowledge proofs. Last week I made a video explaining the theoretical side of zero knowledge proofs. I thought it might be helpful this time to show you some code. So I actually wrote a little game, and what I'm going to do is I'm going to break it down step by step, explain what the code does, and also how it uses zero knowledge proofs to get the job done. So I'll see you inside. All right, zero knowledge proofs in a real world application. Let's go. So what I did is I wrote some code for a game called Guess Who. If you don't know what this game is, essentially you have two players and each player chooses a hidden character. So this one is Maria and this one, I don't know what it is. Let's just say it's Richard or something. And essentially the players take turns trying to eliminate characters until they can finally guess what it is. So in this situation, if the red player guesses Maria before the blue player guesses their character, then the red player is the winner. All right, so this is Guess Who. And this is a great example for a zero knowledge proof example, because how are we supposed to do this on an EVM chain, right? So if I choose Maria as my character, well, I need to somehow put that on the blockchain, but also keep it hidden, okay? There's ways to do this, like I could do a thing called salting and hashing, okay? But it gets really complicated, it's not really efficient. So this is why I chose this as an example for a zero knowledge proof code, because in a zero knowledge proof environment, I can choose Maria, I can put it onto the blockchain, everyone can verify that I chose a character, but they don't know exactly which character I chose. Okay, so we'll get into that a little bit later. Anyways, this is the code that we're going to break down is Guess Who. So here's the code here, okay? It's all on my GitHub. I will put this in the description. We can see it's all here. And in this video, what I'm going to do is I'm going to break down this code, going step by step. What is each thing and what is it doing? And how is it utilizing zero knowledge proofs? Before we begin, let's just do a very quick recap of what a zero knowledge proof is. All right. So on a blockchain like Ethereum, really everything is public. Okay, so how much money I have, how many NFTs I have, what the attributes of those NFTs are. If I'm playing a game, for example, like if I was going to play something like Guess Who on Ethereum, I would enter my character, enter my guesses, and really every time I do this, it's logging this in a public manner. Okay, so this is really not good. It's not efficient for games because if I wanted to cheat, I can just go and look at your records, your transaction history, and I know exactly what you've done. Okay, in a zero knowledge proof environment, which would be somewhere between these two, you can have certain pieces of information hidden, okay? So I would say zero knowledge proof is probably something like, we're using Aleo today, and I would say it's probably closer to this, a semi-private blockchain, because I can really decide what I want to be public and what I want to be hidden, okay? Going a little bit deeper, an example of why this is helpful is, say if I wanted to get an investment from a bank, and the bank has some sort of requirement. You need to have at least this much money to get this loan. Well, as a client, I don't really want to tell them exactly how much I have. Maybe I have 1 billion, maybe I have 1 million, maybe I have 200. Doesn't matter, right? I can prove that I have a certain amount without giving too much information away. And so these guys are happy. I'm happy. Good. I have a video explaining this logic, okay? How I explain zero knowledge proofs, my guide, blah, blah, blah. Okay, I'm not going to go through this entire video, but what I wanted to show you is another example of this, right? So I have this picture here. I want to show you that I know exactly where the Waldo is. So I know where he is, and I can prove it to you without giving you the answer. Okay, so boop, here he is right here. In order for me to take that screenshot, I needed to know where he is. Okay, so now you know I know, but you don't know. Right? So there's that giant picture. You still don't know where he is, but you know that I know. Okay, so that's in a nutshell kind of what a zero knowledge proof is. All right, let's go a little bit farther. So in order to enable zero knowledge proofs in an easier way, so one way is I could write all the code that does this, but it's very complicated. So this is why blockchains like Aleo exist, because Aleo, they bake in zero knowledge proofs in the blockchain at the blockchain level, which means I don't need to worry about the logic for the zero knowledge proof. I rely on them to provide it for me. What I do need to know is how to write for their blockchain. And what they have is a language called Leo. Okay? I am traditionally a Solidity EVM developer. So it was a little bit hard for me because Solidity and Leo, not the same. But if you are a Rust developer, say for example, if you write on the Solana blockchain, which is based on Rust, well, this is going to be very similar. Okay, I use a lot of the same syntax. There's some differences, but I would say this is more similar to Rust than it is to Solidity. It's somewhere in between the two. All right, so that's kind of all the prep I wanted to go through. What I'm going to do is I'm going to go through this code here. Once I've gone through all the code, then I'll kind of show you a little bit more what it looks like if you're going to compile this code and actually deploy this code. So it's important to note that I'm just reading from the README that I created. Okay, if you're actually going to do this, then there's some steps before, right? So you need to install Node, install the Aleo CLI and Git. I'll go through that later. What I'm going to do is go through this code right now. So let's go. All right, starting from the very top. When you deploy Aleo code, the name of the program is very, very important. This is kind of the identifier that the system is going to use to find your information. Okay, so luckily, guess who zero knowledge proof ZKP was not taken, which means I don't think there's another example of a guess who game on the Aleo blockchain yet. So I'm the first, I hope, I think. But anyways, important thing to note here, what you choose to name the program is important because it's the unique identifier. Going a little bit farther down, these are the constants. Well, actually, before we go through this, let me just break down what this code is going to do. Okay, so this game that I wrote, essentially, here's the structure. The first part is there are two players, and these two players are going to start by choosing a character. Okay, so player 1 chooses a character, player 2 chooses a character, and this goes on to the blockchain. Because we're using Aleo, this stuff is private. I will talk about that in just a second. But the first step would be the two players choose their two characters. And then once that is done, the players take turns guessing. Okay, so player 1 would guess, does your character have glasses, yes or no? And then what it's going to do is it's going to check the logic on the blockchain and give that player 1 the answer. Okay, and this is going to happen in a private way so that player 1 knows that they have the correct answer, but it doesn't know exactly what the character is, if that makes sense. The same thing happens in reverse. Player 2 guesses. Okay, and player 1, player 2, they both guess until one of them guesses the actual unique identifier of the character. So say if I'm player 1 and I say, you have character number 12, and that is the correct character, then I am the winner. So essentially the person that chooses the correct character ID first is the winner. All right, and I'm saying all that because I've made this game a little bit more spicy. So in order for the two people to play, they need to put in a bet. So player 1 bets $10, player 2 bets $10, and the winner takes the pot. Okay, so there's actually some gambling elements here to make it a little bit more fun. To make it even more fun, as the developer, I put in a 10% tax. So if you deploy this and people play your game, then you take 10% of that. So say Bob puts in 10, Mary puts in 10, the pot is 20, then the winner takes $18 and you take $2, I think is the correct amount, right? So kind of cool, a little bit more spicy. So that's kind of an overview. I've already introduced this. Let's move on to the next part. I started to introduce these things. Each player, when they start the game, they have to choose their character. Okay, and here's the attributes to that character. Let me zoom down all the way to the bottom. Okay, this is happening on the DApp level, which I'm not going to explain today. I'm just explaining the Aleo code. But essentially the DApp, it helps the player do this without having to write the code. Okay, so you can see here I have 24 characters, and they all have attributes, and I've balanced this so it's kind of equally balanced through everything. But you can see gender is male, non-binary female, the hat is a binary, right, true, false, etc. So here are all the attributes, and that's what's getting fed into this struct here, right here, the struct. Okay, so the uint, this is to save on data. It's actually, I think it would, the front end is looking at a string and that's converted to a uint just to save on data. Glasses, the facial hair, hat, these are bools, so yes or no. So that's the character struct. This is actually private. So when the player 1 chooses their character, I put it in and the system acknowledges that and records that, but it's in a private environment. So that's that, right? That's handled by the the Aleo network itself. Moving down a little bit, another struct we have here is the game state, right? So this is holding all of the game data that we need. Things like who is player one, who is player two, which character, whose turn is it, all that kind of stuff. And again, if we're doing this in a record on the Aleo network, this is all private, so no one can view this except from the game itself. Same thing here, we have mappings. Okay, so we have two mappings here for the game and the player balances. Again, this is, so in Solidity, this could be accessed, but in Aleo, this is actually private. And so these things are updated by the game, all private. All right, so that's just a very quick overview of kind of the variables that are handled here. Again, because we're doing this in Aleo, a lot of this is hidden by default. One thing to note is a constant like this is public. So that means, and I thought it would be important to make these things public, right? So who the developer is, how much the tax rate is, how much the game cost is. These are public. I think that makes sense to make these public. These are private, which makes sense to make these private. Okay, let's move on to the actual, the fun stuff, the chunky game logic. So something to note right away is we have two different types of functions, or two different types of logic here. We have transition and we have function. Okay, and this is a big difference between something like Solidity and Leo. On Solidity, essentially, it's all functions, really. And functions are publicly viewable, or what happens in the function is publicly viewable. Okay, but in Leo, the way they handle this is having two different types. Okay, and the reason why this is important is the things that happen in a transition function is private. Okay, so this is what I call as the player one, right? I enter my address, I enter my character, okay, and then it's going to crunch this information, it's going to pop this out and feed this into the game logic, okay? And then this finalize create game function, this is actually going to update the public blockchain state, and it's going to take my information and put it in here. And so the reason why we're doing this is to kind of separate these two things. In order to preserve the privacy of which character I chose, we've separated transition and function. Okay, and this breakdown I've done for all of these, right? So transition join game, function finalize join game, transition ask question, function finalize ask question. And you can see, right? It's the same transition function. Transition function goes all the way down through all the functions. And this is so that we can maintain privacy while also updating the blockchain. Okay, so I guess I could go through all of these, right? So again, so for right now, just ignore the function. I'm going to show you that we have a transition here for creating the game. We have a transition here for joining the game. Okay, so really what's going to happen here is player one is going to create the game, and they enter their character. And once that is done, it gives them a game ID. And then with that game ID, the second player can join, right? So again, they take that game ID, they enter their address and their character. Okay, so that means player one created the game with their character, and then player two can join the game with their character if they know the game ID field. Okay, so that's the second transition. The third transition is asking questions. So this is when the players take turns. Okay, player one, where is it here? They ask a question and they say what they think it is, right? So something like, facial hair, yes, which means does your character have facial hair? And then it pops out the answer like, no, it does not have facial hair, right? So here, value, no, it does not. Okay. And essentially, the players are taking turns calling this ask question function until they actually are able to guess the character. Okay, so that's the third transition, and the fourth transition essentially is if the game has finished, which happens. So the game finishes once player one guesses the correct character number. Okay, when that happens, the game is then closed, and that person is the winner. Okay, so once the game is closed, player one or player two, whoever wins, they're able to claim their reward. And so to do that, they have to call this function. By calling this function, that the winner takes their money, and it also kind of cleans up the game. Okay, it ends the game. So yeah, we also have this transition for ending the game. So those are the transitions. Maybe that's a little bit fast and confusing. But let's move on to the next part, which is the actual game logic here, the finalizing functions. Okay, so let's take a look at this one, the finalize game function. So essentially what's happening here is it's going to take this information from the player when they call the transition. It's going to package all that, update the game state, so everything is on the blockchain. And like I said, this game state is private. The character that they chose is private. One thing to note here is that, right, when player 1 starts the game, we don't know what player 2 starts. So essentially it just sets everything as default, right? So 0, 0, 0, false, and just kind of sets all this up as default. When player 2 joins the game, right? So this is the next one. So player 2 joins the game, then it updates that player 2 character. Okay, and like you see here, what it's doing is it's updating the game state. We don't player 2 doesn't know what player 1's character is, but the game state does, and so it's taking that in and putting that here. So again, all this is private. So by the time finalize join game has been called, then both people have chosen their character, and now it's ready to start the ask question. This part is pretty interesting because this is where really the zero knowledge proof game logic comes into play. This is where it actually really is happening, right? So I ask a question, it checks your question, it checks my question against the game logic, and then gives me an answer. And it does all this without actually revealing what you chose. Okay, so let's see here, right? So it's getting the game state, and again, it's from the mapping, so it's hidden. It's checking, okay, am I the right? Is it my turn or not? It's actually comparing my question to the game state, and it's saying, what was my question correct or not? And then it's returning this and updating the game state, right? So, okay, now my turn is done. This is important, right? So it's in this here, it's also checking, is the game over, yes or no? If I was able to choose the correct character right here, if I was able to choose the correct character, then the game is over and you win, or I win, whatever. Okay, and then just to summarize, to sum up this discussion, like I said, once the character has chosen the correct character, then it's going to finalize the game, it's going to give the money, and then the game is over. All right, so this video is getting a little bit long, so let's try to wrap this up. I've gone through all this code here. Now I'm going to show you kind of the final steps of what you would do is deploying. In order to do this, I'm actually going to go into my Visual Studio environment because I've done the npm installs, I've done everything. Important to note here is if you want to actually do this yourself, you're going to need an Aleo wallet. The easiest way to do that is to go to the provable tool. And for example, create a new account, I can just click this. It's going to give me everything I need, the private key, the view key, the address. You can do this in the Leo CLI as well, which is what I did. But if you're a little bit squeamish on that front, then you can do it here. Another thing to note is if you need testnet credits, there's you can go to their website. Let's see, it doesn't have it here. It doesn't have it here, but you can go to their website. You can send a text message. It sends credits to your account. That is kind of not helpful. In my opinion, another way to do it is on the Discord. I've given you the link here. You can click this. You need to verify your count and all that kind of stuff, but then you can claim credits that way. Okay, and the final thing I'm gonna where to go? Oh no, I closed it. The final thing I'm gonna say before oh no, it's all gone. Whatever. Final thing I'm gonna say before showing my Visual Studio Code environment is I recommend installing this plugin to Visual Studio Code. This is going to help you when you're compiling stuff because, here it is, let's just go here. When you're compiling things, you may have a lot of errors and having that is helpful. So to wrap up this video, let's show you what to do. So let me just copy this first. What I'm going to do is I'm going to show you my Visual Studio Code environment. I'm going to run all this in the terminal. This is to check that I have the correct stuff installed, right? So node leo git. Once I've check these things, then I will then show you what it looks like when you build this and actually start to deploy this to the blockchain. Okay, so give me a second. Let me switch over to the Visual Studio Code. Do I have it? Oh no, here it is. Let's see. Why can't I show you this one? Nope. Give me a second. I'm going to pause the video. Okay, there we go. I found my Visual Studio Code. So you can see this is all the same code that we just went through. It has the characters, the game state, all the same stuff, exactly the same code. What I'm going to do now is just very quickly show you that this works. So first thing, like I said, you're going to want to check that you have all the correct stuff installed, like Node, npm, Leo, Git. Click enter. Here are the versions I'm using. I think these are just the newest versions, so you can use that too. All right. Just very quickly, let me show you what this looks like. So when you create a new Leo, where is it? Let me just go quickly here. When you create a new Leo environment like this, Leo new guess who, okay? It's going to create all these folders. So I'm not going to do that now because I've already done that. But if you just follow the steps in my README, it will set it up just like this. I'm going to close this. Okay. And what I'm going to do now is, here is the main file that we're looking at. Okay, so all the stuff. I'm going to then build this. Okay, so you can see I already have a build file. So the first step I'm going to do here is Leo clean. And what that's going to do is, you see it deleted that file. Okay, so clean the outputs, clean the build. If you want to set up a fresh environment, or if you have set up a fresh environment, you don't need to do that. But if you make a mistake, just Leo clean helps. Okay, and then the very next step would be Leo build. What this is going to do is it's going to compile all this code. And if I show you something a little bit interesting here, what it did is it's going to take that code and put it into opcode, right? Well, what you would call opcode in EVM. So it got rid of, so here's this is kind of human readable, right? So it has the function names, things like that. Here, it's kind of chunked that into opcode. Okay, so this is hard to read. That's what, when you say Leo build, it does that. Okay, it also makes things like this and the README, all that kind of stuff. All right, the next step, if you're ready, would be Leo deploy. I don't know what this is going to do. In order for that to happen, you need to have, I don't want to show you this file because this is my EVM, but actually let me pause for a second and check my EVM. You're going to want to put your private key in there, the one that you created when you went to the Leo tool, and that's your actual wallet address. All right, so to wrap up this video, let me show you this magic. So we have our Leo code here, we've built it here. The final step would be Leo deploy. I'm going to do it. It's going to deploy again, which may have an error because I already have a guess who ZPK, but let's see what happens. Boop. So you can see it's compiled. It's creating deployment. Let's see, there we go. Okay, so you see I don't have enough credits in my wallet, which is totally fine. I actually didn't want to deploy it, but when you do Leo deploy, it should look something like this, giving you the information of how much it costs, all that kind of stuff. Okay, so thank you for watching this video. Maybe in a later video, I can go through the application that I've created here. I hope it was helpful for you. See you in the next video. Goodbye.